My name is Professor James Alsop. I'm here to tell you a little bit about one of our new master's programs at the College of Innovation and Technology, our Smart Manufacturing program. So to start with, we're looking at the evolution of industry as it's been developing over the last couple of hundred years. And we've seen a tremendous amount of acceleration. But if you go back to around 1800, the first what we call Industry 1.0 was in mechanization, water and steam powers. And then it took about 100 years for Industry 2.0 to come out, where you're looking at mass productions, electric power, assembly lines starting to make their impact. And then another 100 years for what we call Industry 3.0, where computers, automated production, and electronics start to play out. 4.0, you'll notice that the gap in time was much less, where we only went 10 years to where cyber physical systems, our Internet of Things, networking, machine learning started to make their impact. And now we're leaning towards another transition to what we were calling Industry 5.0, with human-robot collaborations, cognitive systems, and customization. Motivations for why we're building a smart manufacturing program here. Well, Michigan is home to one of the largest workforces of manufacturing in the U.S. There's an estimated 587,000 manufacturing employees in our state, with only approximately 1 in 10 in the advanced manufacturing industry. But still, we're producing $101 billion through our industry. And the average compensation that we're finding is around $85,000 to $86,000. Right, so Michigan, it continues to be this prime state for entrepreneurs, growing businesses, families. We have the history, we have the infrastructure that we can grow it and evolve with this. You'll see several rankings have come out, and this is coming from our Michigan Economic Development Corporation, where it's the #1 economy with a population over 2 million from Bloomberg, the #3 state for sustainable development, the #3 state to dominate EV battery manufacturing in the future, and the #10 state for business inside of here. So we have a lot of opportunity with this new program. And now, as we start to see technology impact business and industry, we developed program goals, a set of what we want to develop a smart manufacturing program to do. And #1 was to equip students with an in-depth knowledge of smart manufacturing technologies, developments to include additive manufacturing, collaborative robots, artificial intelligence, Internet of Things, and beyond. #2 was to prepare students with the capabilities of developing, selecting, deploying, and managing smart manufacturing solutions by assessing industrial needs for real-life applications of digital upgrading. And 3, to prepare students for the ability of manufacturing management and the enthusiasm of enrolling themselves in the process in a lifelong learning setting by leveraging the power of smart manufacturing. If we look at the curriculum that a student passes through, we have our core courses, and these are just going to provide students the general background on how manufacturing is changing in the future. Start with DMT 501, Smart Manufacturing and Industry 4.0. How do we start to merge manufacturing with robotics and Internet of Things? 520, where we're looking at 3D printing, 3D scanning, and additive manufacturing. 522 with artificial intelligence and digital twin for smart manufacturing, and 526 collaborative robots and automation in smart manufacturing. After that, students will select a concentration, one of these options. There's 8 credits or 2 courses involved on them, and it's dependent on student interest. But you might have a student that prefers artificial intelligence, digital twin, and AR/VR in manufacturing. That's going to be a concentration track built on courses in automation, machine learning, augmented reality, and virtual reality. Or maybe a student's more interested in industrial Internet of Things and cybersecurity for smart manufacturing. That's where you'll take courses in security, blockchain technology, how clouds can impact your businesses. Digitalization of manufacturing systems. That would be where a student looks at lean manufacturing, digital transformation, digital finance, and quality control. Or maybe they are interested in collaborative robots in manufacturing. That would be this robot and human interaction role. Finally, the curriculum's completed with an electives or thesis option. Option 1, a student would take 2 more courses from any concentration. Or option 2, a student takes 2 semesters of thesis research with a faculty advisor. So our admission criteria and graduation requirements for smart manufacturing. Well, we're going to be pulling from a range of different backgrounds. You'll have students that will be successful in this program coming from business, coming from computing, engineering, management, and technology. They're all welcome, and we'll all be able to complete this program. Our admission criteria, we're looking for a 3.0 GPA. That's recommended. If you have a GPA less than that, but you have experience in research, or if you have an experience from industry, please apply. We'll be looking at those on a case-by-case basis. We also allow up to 8 credits to be transferred into our program, and there's minimal programming and mathematics requirements. In order to graduate, there's the 32 credits or 8 courses with a minimum GPA of 3.0 in the program. And that'll do it for us. I hope that you consider smart manufacturing in your future.